HOD, Department of EEE from DBS Institute of Technology, Kavali. So, up to that, we have whatever we have seen in the last topics, that is what is demand side management and what are the basic concept of this demand side management and what is the need of this demand side management and what are the different benefits of this demand side management. Now we have see that what are the basic techniques, different types of the techniques in demand side management. Demand side management, there are different techniques, that is time of day pricing and metering. Time of day pricing and metering. So time of day means TOT, time of day pricing and metering. And then multi-utility power exchange model. Multi-utility power exchange model. Next one is load management. And then load priority techniques. Under these load priority techniques, there are peak clipping, peak shifting, strategic conservation and energy efficiency improvement. So there are the different techniques of DSM must be there. In these techniques, there are time of day pricing and metering, multi-utility power exchange model and load management, load priority techniques, peak clipping, peak shifting, strategic conservation and energy efficiency improvement. So first you see about the what is the time of day pricing. What is the time of day pricing is the rate which vary according to the time of the day is called time of day pricing. So according to the time, so there is a morning session, there is afternoon, night and midnight, whatever it may be, according to the time, the date will, whatever the rate will be fixed. Rate varies from morning this much, afternoon like that, peak hours or non-peak hours, like further the time will be vary. Then vary, the rate which vary according to the time of the day is called time of day pricing. So generally these time of day pricing already producing in India of HV installations, industries and large commercial installators also here used. And it should extend to other installation India from all types of the loads also. So this time of the day tariff is a tariff structure in which different rates are applicable for use of electricity at the different times of the day. That means the cost of it, some using of 1 unit of electricity, it will be different in morning and afternoon and evening and nights. The rate will vary according to the time of the day is nothing but the time of day pricing. Under the time of day pricing, consumers will have pay more for power consumed during peak hours and less during non-peak hours. For according under time of day pricing, consumers will have to pay more for power consumed during peak hours and less power under non-peak hours. These will be made mandatory for industries and other consumers with a contracted load of 500 kVA and more coming under high tension categories. And this time of the day shifting, whatever the system may require, the industries to reschedule their working shifts. So industries will be planned depend upon this time of the day. They have to be rescheduled the working shifts, while utilities have to install special meters that could record the time of the how much of the for the industries, if some one part they have to be shifting the working shifts, but and they have to be say that they have to be installed special meters that will be the time of consumption. Due to the recording the time of the consumption, they have to be installed the special meters. So time of the day, the rate which vary according to the time of day is called time of day pricing. Under this time of day pricing, consumers will have to pay more for power consumed during peak hours and less during non-peak hours. And the industries and other consumers will be contract load to 500 kVA and more coming under high tension categories. And these time of the day systems may require industries to reschedule working shifts, while utilities have been installed special meters that could record the time of consumption. For example, when you see how much time of the use and what are the applicable rates. If suppose normal period, that is 5 AM to 5 PM. So normal rate of energy charges. If evening peak load, that is 5 PM to 11 PM, 130% of normal rate of exchange energy charges. In off peak loads, that is 11 PM to 5 AM, 90% of normal rate energy charges. So depend upon the time. So under the normal period, it will be charged normal rates. When it will be the peak load period, then it will be charged 130% of normal rate of energy charge. When there is half peak period, it will be takes 90% of normal rate energy charges. Next one, what is multi-utility power? Next model of demand side management is multi-utility power exchange model. So this multi-utility power exchange model means all utilities connected by a grid. The total whatever the utilities must be there, it will be connected to the grid. So whatever you have to handle or manage this peak demand, grid shifting is allowed. Grid shifting is allowed. So what is the major condition of this multi-utility power exchange model is peak load handling capacity is less than 10% difference between peak load and average load. So all utilities are connected to the grid. In order to manage the peak demand, grid shifting is allowed. What is the condition? Basic condition is peak load handling capacity is less than 10% difference between peak load and average load. And what is the another technique of this demand side management? That is load management. Generally, this load management is a process of balancing the supply of electricity load by controlling the load. By controlling the load. The load management means you have to manage the load, whatever that means whenever it will be, whenever you have to manage this load, it will be reduce for whatever reduce demand for electricity during peak times. So you have to use load management technique. So this load management technique, whenever you have to taken this load management, it changes the consumer's electricity use pattern. So they have to some for this load management, when you have to use this type of techniques, this change the consumer's electricity use pattern. And this technique which improve the effective utilization of generation capacity. When you use this load management technique, this will be improve the effective utilization of generation capacity, and it will be encourage best usage of electricity, and it is for reducing outages and improving reliability, it will be reducing outages and improving relay. So this load management involves planning, developing and implementation program. So load management is a process of balancing the supply of electricity load by controlling the load. Generally, in real time, by the use of this frequency sensitive relays, triggering circuit breakers must be there. So load management is used to reduce demand for electricity during peak time, that is load factor is equal to average load by maximum demand. Like that we have taken that average load by maximum load. So load management, when you have to use this load management, you have to change the consumer's electricity use pattern, and this is improve the effective utilization, and it will be encourage the usage of practice, and it will be reduce the outages and improving the reliability. And so this load management is equal to load factor is equal to average load by maximum demand. Load factor is equal to average load by maximum demand. Keep the value of the load factor to be high. The value of the load factor must be, so when you have to manage the load factor is average load by maximum. Always you have to keep the value of the load factor is to be high. Different load control techniques are available, that are under this load management techniques. There are different techniques must be there, controlling techniques, that is direct load control technique, local load control technique, distributed load control technique. Direct load control technique, local load control technique, and distributed load control technique. So there are the different load techniques under this load management, direct load and direct load technique, and whatever the local load controlling technique and distributed load controlling technique. So when you first see about this, what is direct load control technique? Direct load control technique, that means in this direct load, utility control the consumer's load without any interaction. So that is, for example, power lines, carries, or ripple control systems, like that. Whatever the utility must be there for the consumers, without interaction, we have produced the load. So utility control the consumer's load without any interaction. Most of the times there will be systematic switching of the supply to areas within the supply region, such that each area turns to loss supply. So in some cases, some of the times there is the switching of the supplies. So for that areas, when there is will be off, such that each area turns to a loss power. Utilities or municipalities in these cases would try to publish or announce a schedule so that users can plan their usage of energy during this period. So under this direct load controller, before whatever you have to done, before you have to publish or announce whatever this, for this we are turning off, for this we are turning off, like that when you have to announce, so that they can to plan their use of energy during that period. So this is about direct load control technique. Next, local load control technique. So under the direct load control technique, utility control the consumer's load without any interaction. And if why? Because most of the times it is switch off the supply of areas, at that there is more loss of energy. So before that, whatever we have to give some announcement, so the consumers will be planning their usage of energy during the period. And next one, that is a load priority. Local load control techniques. What is local load control technique? Consumer control the load. Here, when you observe here, utility control the consumer load without any interaction we have to providing. But here, consumer will take care to control the load. And one method is to have a circuit breaker at a consumer premises. There is circuit breaker must be there in the consumer premises. So they have to be control the load. And next one, when the load exceeds the predetermined value, circuit breaker will operate and supply is switched off. So if suppose they are using the above the low predetermined value, then automatically when you observe that, it will be tripping. Circuit breaker will be trip off. It will be switch off. This is local load control technique. The consumer control the load So here one method is to have a circuit breaker at the consumer premises. When this load exceeds the predetermined value, circuit breaker will operate and supply is switched off. Next one is load under this. Third one is distributed control techniques. See, distributed control technique. So in this distributed control technique, in this technique, consumer control their load in communication with utilities. In the second one also, the local load, the consumer will be control. Here the consumer control their load in communication with utilities. Applicable for large industrial consumers. For large industrial consumers, they have special contracts such as interruptional load. Interruptional load. Even after what are the B and C implementation, if there is a mismatch, then A is applied priority wise, essential living needs, luxury and con. That means even after B and C, and B means local load control technique and distributed control technique will be implement, there is a mismatch, then we have to apply direct load control technique. That is in terms of priority, we have the essential like living needs, luxury and commercial. Next, in this whatever the load techniques, there is that different techniques must be there, that are peak clipping, valley clipping and load shifting must be there. So what is peak clipping? Peak clipping means the reduction of the system peak loads, one of the classic forms of load management. That means it is aimed or decreasing the demand during the peak hours. It is the decreasing the demand during the peak hours. That means reduction in peak demand, controlling the equipment and controlled tariff rates. Controlled tariff rates. When you observe here, peak clipping means shifting electricity consumption from peak to non-peak hours. So it will be some peak hours will be there. Whatever the peak clipping must be there, it will be shifting the whatever the amount of demand must be there, it will be shifted to peak to non-peak hours. So shifting electricity consumption for peak to non-peak hours. One of the classic form of load management. It is the one of the major form of the load management. Here some of the consumers will be applicable switch off by direct load control technique. There are the control must be there. Here some consumers will be appliances switched off by direct load control techniques, and it will be more beneficial for large industry consumers. These peak clipping will be more beneficial for large industrial consumers. That means peak clipping. So this is very important for the developing countries. So this peak clipping will be shifting electricity consumption from peak to non-peak hours. So this is the one of the classic form of the load management, and here some consumers will appliances switched off by direct load control technique. It is the more beneficial for large industrial consumers. Next one is load shifting. So we have to shift the load, increasing load during half peak hours. So when you observe here, low energy, equal energy before, how much of the energy will be there, and when will be shift after, how much of the energy will be there. So it will be shifting the load, increasing load during half peak hours. So in the peak hour there is a large much of demand must be there, so you have to shift that much of the load to the half peak hours. Building half peak loads. Building half peak loads. So load shifting means reduction of utility loads during period of peak demand. During period we have to reduce the utility loads during the peak demand, and building the loads in half peak period, and you have to build it the loads for half peak period. And some whatever the appliances must be there, you have to switch off during peak demand. So at that means you have to shifting the load. So whenever you have to shifting the load, what if suppose what some of the if suppose when you take in the washing machine, so at this load point when you have to switch off for that point, and you have to put that you have to go through that washing machine, turn on the washing machine during the half peak periods. So you have to switch off the during peak periods and it will be turned on to the half peak periods. That is the load shifting. The next one is different techniques of DSM, that is the valley filling. Valley filling. So valley filling means increasing load during half peak hours. So you have to increase the load at half peak hours, building of peak loads. So when you observe, this is the valley filling. Valley filling means improve the load factor. You have to improve the load factor, and whatever the load will be, this building load in half peak period. Building load in half peak period. That means some heavy appliances, irrigation pump, water heater during peak hours and on during half peak hours. Valley filling means, so whenever you have to irrigation purpose or when you take the water heaters or washing machine, whatever you have to take, for in the peak periods, peak hours, you have to switch off and it will be turned on the half peak hours. This technique is known as valley filling. Valley filling. Next one is strategic energy conservation. Strategic energy conservation. What is strategic energy conservation means? Conserve the energy. For example, photosensitive switches for street lighting and reduce kVAR of the load. It will be conserve the energy is nothing but the static energy conservation. Next, strategic load growth. Strategic load growth. It is the supporting for the valley filling and it will be the meet the load, whatever the load requirement you have, it will be meet the load requirement. That means we have to improve the load growth. That means strategic conservation is the load shape change the results for utility conservation. For utility conservation, so it supports the valley filling and it will be the meet the load requirements. And then flexible load shape, these are the shape of the load. This means the utility is to allow to adjust the load shape to meet the reliability constraints. The utility is to allow to adjust the load shape to meet the reliability constraint. To meet the reliability constraints. And the consumers are give incentives for reducing level of service. So whenever you have to flexible this load shape, the consumers will give the incentives for reducing the level of service. This is about the flexible load shape. This is the how we have to be allowed to adjust this load step to meet the constraints. To meet the constraints. Next one, there is energy efficiency improvements. So under this energy efficiency improvement, there end-use energy conservation, least cost utility programs and promotions of high energy technologies. So these are energy efficiency. So there are the some of the techniques in the DSM must be there. There is time of day pricing, multi-utility power exchange models and load management, load priority techniques and peak clipping, peak shifting and valley filling and strategy conversion. In the next class we see about the what is the energy efficiency improvement.